Okay, today we're going to look at Lesson 4, and our I can statement or learning objective is I can graph and write quadratic functions in vertex form. So we're switching gears a little bit. We've been factoring quadratic expressions. Now we're going to look at quadratic functions. We're going to talk about what those look like and how you can pull different information from the function or the equation and how to graph that. And we're going to look at those in the specific vertex form. Okay, and throughout the lesson today, after we talk about vertex form, we're going to look at a graph of a quadratic and see what it looks like and see how it can change. And so you'll notice that I have to switch back and forth between this screen and this screen, okay? And normally when I am recording a video, you probably noticed, I'll write some stuff down, or we'll talk about some stuff, I'll pause, write something else, and go back and forth. Well, in order for me to do that, I have to go to this screen. So you'll see me switching back and forth, and I do apologize for that in advance, but I just couldn't figure out a better way to do this. So just a heads up there. I expect you to have something to write with, something to write on, a notebook preferably, and then I will upload the example pages that I'm going to use. I'll upload those into Google Classroom so that you can have those if you want them, and if they may help you, you're welcome to print them off and try them on your own. Okay, so with that being said, let's get started. First, we need to look at the parent function. So the parent function is the most basic function of that type. So we're talking about quadratic functions. So the parent function is f of x equals x squared. Or you might see y equals x squared. Those are the same thing. This is function notation. This is equation notation. Okay, so those mean the same thing. You'll see some problems that have f of x today, and you'll see some that have a y. Okay, but we're going to look at vertex form. So that's f of x equals a times the quantity x minus h, close quantity, squared, plus k. Now, that should look familiar to you because it's kind of like the point-slope form that we did. And the reason we spent so much time talking about point-slope form is because it relates so closely to what we're looking at here, okay? And we're going to make a little side blurb over here that if you understand what's going on with this and what the a does, what the h does, what the k does, then you can apply that to any of the other functions. So here's a generalized example. So y equals a times the function of x minus h, plus k. And I'm sorry, that's squared. Didn't need to be there. So you can put all kinds of different functions in this same form. Look, we could do a cubic. So y equals a times x minus h cubed plus k. You could do absolute value. Y equals a times the absolute value of x minus h plus k. That should look familiar because we looked at that back in Unit 1 or 2, I think. And then you can do it with all different types. So there's another one that's a over the quantity x minus h, and then plus k. And like I said, if you understand what a, h, and k do to the quadratic function, you can apply that to any of the other types of functions, okay, including linear, the point-slope form that we talked about way back, okay? So with that, you need to know that a, if it's positive, it opens up, and it looks like this. It is a U shape, and the vertex is at the bottom, and that's the minimum. Because that means we know the lowest value on the graph. We don't know the highest because it goes on and on forever. Right? If it's negative, that means it opens down. So it's an upside down U. The vertex is at the top, and that's the maximum. Again, On this one, we know the highest value, but we don't know the lowest because it goes on forever. Okay? If A is less than 1, then your graph is going to be fatter or flatter, however you want to think of it. So it'll be more like this. If A is greater than 1, you'll have a skinnier U. And that's because A is like the slope. So if it's a fraction, we know it goes up slower, so that makes it flatter. If it's greater than 1, then it's going up quicker, it's steeper, and it makes it skinnier. Okay? So you can tell all that just by looking at the A, that first number in front of the parentheses. Okay? Next, you can find the vertex. The vertex is H, comma, K. Now, just like before in point-slope form, we said you can't trust the x. So in the equation or the function, it looks like minus h, okay? But the vertex that we pull out is just the h, okay? Because there's a negative in there, a minus, so that tells us it's the opposite, okay? So remember, you can't trust an x, so it's always the opposite of what it seems. So we can get the vertex. You can also find the axis of symmetry. And the axis of symmetry is if you have that U shape, and there's your vertex, that axis of symmetry is what goes right down the middle. You could fold the graph over that line, and it would match on both sides. So the axis of symmetry is x equals h. So whatever your h is in your vertex in your equation is your axis of symmetry. Okay? You can also find the domain. Now, the domain for a quadratic function is really easy. It's all real numbers, always, because the arrows go on and on forever on both sides, so we don't know where it's going to stop. So there are some different ways to denote all real numbers. You can say all real numbers. Sometimes you'll see this capital R. You might see an inequality, or you might see interval notation. And I think, oh, forgot to throw a negative there. So negative infinity to positive infinity. All right, I think that Math Excel is going to ask you for some interval notation, but just make sure you know this is the all real numbers if it's an inequality. This is all real numbers if it's interval. Like I said, I think Math Excel wants interval notation for your assignment. But you need to know that all of those mean the same thing. We can also look at the range. Now, the range is going to be a little bit different. If you have a minimum, so if it opens like this and you have a minimum, then your range is going to be y is greater than or equal to k. So you find that k value, that part of your vertex, and if your quadratic opens up, then your range is going to be all the values bigger than k. And in interval notation, that would be a bracket, k, and then infinity. Okay? If you have a quadratic function that opens down and you have a maximum, your range is going to be y is less than or equal to k. And so that would be a negative infinity, comma, k, and k's in the bracket. Okay? And occasionally, if it asks for the range value or the minimum or maximum value, it just wants the y or that k. All right? So if it asks you for the minimum value, it's just k. The maximum value is just k. All right? So just by looking at a quadratic function, we can pull out all of this information. Okay, so we can learn a lot just by looking at the equation. And we're going to look at how to do that here in just a little bit. One thing I did forget to mention is that this shape, the shape of a quadratic, is called a parabola. Okay, parabola. You'll hear me refer to that. You'll see it. You need to get familiar with a parabola. That's the graph of a quadratic function. That's the shape or that curve. Okay, now we're going to look at a graph, and I'm going to type in some quadratic expressions, and we're going to see how they change. Okay, so you can see what the numbers mean, and then we'll look at doing some actual examples. So if we come over here to the Desmos calculator, I typed in the parent function, so x squared. So this is your most basic parabola, your most basic quadratic expression. Okay, we talked about how if a, or the number in front, is less than 0, so let's do, or less than 1, sorry. So let's say it's 0.25 x squared. Okay, you can see our new one is fatter. Okay, it's wider. All right, we could change that and we could do one larger than 1. Let's say 1.5 x squared. Okay, so that one's got skinnier. All right, what about if we do a negative x squared? What happens? It flips down, so it opens downward. All right, let's take out these. Let's do another one. What about, let's add some stuff. So in parentheses, if we have x minus 3 squared, close parentheses, then square it. So sorry. There we go. So what's happened to our parabola? We went from here to the right 3. So that's how we said it's, you can't trust the x, so it's the opposite of what it seems like. So if you go over negative, if it says negative 3, that means you really go to the right 3. All right, if we add a number on the outside, let's change it. Let's make it smaller. There we go. So on the outside, that number moves it up or down. If it's positive, it's up. If it's negative, it's down. Let's see, we can add a plus on the inside. So plus 3 moves it to the left 3. We can throw a number out front. We can say 0.5 so that you can see the difference here. The purple line is fatter or flatter. It's moved to the left 3 and down 2. All right, and so that's how the transformations work. So we can move them left or right, up, down. We can flip it, again, by putting the negative out front, and that turns it upside down. Okay, so we're going to look at how those different transformations affect the graph and how your equation or your function changes. And as I was talking about that, I realized that we did forget to make a couple notes. All right, so let's see, let's just add them down. Or no, we can go back up here. I apologize. So this tells you right or left. If you go to the right, it's negative. The left is positive. K tells you up if it's positive, or down if it's negative. Okay, so that's just a shift. Left or right, up or down. Okay, and the H, it's always opposite of what it appears. So keep that in mind. All right, so now with all that being said, we're going to do some examples together. Okay, so I do apologize. When I copied these, it cut off some of my words, but you should be able to see what I'm talking about. So we're going to start with the parent function, so x squared, and we're going to pick out the vertex, the axis of symmetry, the domain, and the range. We're going to look at filling in a table of values, and we're going to look at that on the graph. So the vertex, we know, is HK. Well, I don't see anything in parentheses with x, and I don't see anything added on the outside, so your vertex is 0, 0. Okay? Your axis of symmetry is x equals h, so just x equals 0. Our domain is all real numbers, so negative, that should be parentheses. Let me fix that. So parentheses, negative infinity to positive infinity. And our range is, let's label that. So our range is k to all real numbers. Okay, so k to positive infinity, so sorry. Because A is positive, so we're going up with our graph. So we can plot the vertex on the graph, and let's see what the values will be. All right, so if we plug in -3, that's -3 squared. That's 9. So -3, 9. And then -2 squared is 4. -1 squared is 1. Then we have 0, 0, because 0 squared is 0. 1 squared is 1. 2 squared is 4. And then 3 squared is 9. Okay, so this should give us a nice U shape. Now, I'm going to sketch this. I'm not the best at sketching graphs, so just bear with me. Oh, that one's pretty good. But we want to make sure it's rounded at the bottom. It's not absolute value. It's not those straight lines out to the side. Okay, it does make a U shape. Now, I'm going to show you a trick to graphing that's going to make this easier. Okay, you only have to do one side. Okay, because you notice they're the same on both sides of the vertex. So if you get one side, you can just mirror it to the other side. Okay, and so what I want you to notice, if you go, let's just look at the positive. So if you go from 0 to 1, you go up 1. 1 to 4, you go up 3. 4 to 9, you go up 5. So we're going to look at something called 1A, 3A, 5A. Okay, and that's what we can use to graph. So you start at your vertex. All right, our A on this one is just 1. That's what's understood up front. So 1 times 1 is 1. So that means we go over 1, up 1. Then we have 3. 3 times 1 is 3. So let's see. So we'll change that to 1, 3, 5. So 3. So we'll go over 1, up 3. Then 5. From there, over 1, up 5. So you can do that every single time with your quadratic function or equation that you're graphing. Okay, you do 1 times A, and that tells you to go over 1, up however many. And then from there, you go over 1, up however many, 3 times your A, and then 5 times A, you do the same thing. Okay, and I feel like that's hard to explain, but once you actually do it a couple times, it's not that bad. After you find the vertex, it's really easy to get some plots pointed without filling out a whole table. Okay, so let's move on to the next one. So first, let's just label some things. And we didn't do this last time, but I'm going to now. So A is a positive 1. H is 3, K is 5. So we're going to use those three numbers to pick out everything. Our vertex is 3, 5. Our axis of symmetry is x equals 3. Our domain is, again, all real numbers. And our range, so our range is positive. Our A is positive. So that means we're open and up. Okay, and so our range is going to be y is greater than or equal to 5, or interval notation, 5, all real numbers. Okay, now let me show you how we're going to graph this, and we're going to use that 1, 3, 5 method. Our vertex is 3, 5. So I'm going to go to 3, 5 on our graph. Our A is 1. So 1 times 1 is 1, 3 times 1 is 3, and 5 times 1 is 5. So from here, I'm going to go up 1 over 1, or over 1 up 1, over 1 up 3, and then I ran out of room. To do the other side, I'm just going to mirror. So here's one, and here's the other one. And we can graph that. And there we go. Sometimes it'll ask you to graph the axis of symmetry. And so you would just make a dotted line down through the middle, through your vertex. And there you go. Okay. Our next one, we're going to do the same thing. So let's go ahead and look. A is -2, so that means it opens down. Okay, so we're upside down this time. Our H is -4, and our K is -1. So that means my vertex is -4, -1. Remember, you can't trust an X, so it's not really a +4, it's a -4. Our axis of symmetry is X equals H, so our -4. Our domain is all real numbers. And our range is, let's see, so it opens down. So it's going to be, remember, y is less than or equal to -1. So that's -∞, comma, -1. I don't know why I was about to write a 7 there, but that doesn't make any sense. So -1 and the bracket. Okay? Now let's graph it. We're going to find our vertex. So -4, -1. Then we're going to use 1A, 3A, 5A. So this time our A is -2. So 1 times -2, 3 times -2, and 5 times -2. So that's -2, -6, and -10. All right? So that means I'm going to go over 1, down 2. From there, over 1, 2, 3, 4, 5, 6, down 6. And then I ran out of room, so I don't have to do any more. All right, and then I'm just going to mirror on the other side. Okay, and based on what we've talked about, we said if the A is negative, it's upside down. If that number is bigger than 2, it's going to be skinnier because your slope, you're going up quicker or down quicker. And so that all checks out here. I didn't do a very good job of connecting those dots, but you all get the picture. All right. Now, on Math Excel, you're going to have to do the same kind of thing. You're going to have to fill out the parts. You're going to have to graph on Math Excel, use the graphing tools. But you're going to follow the same process that I am. Okay? Now we're just going to look at some graphing. So we're going to use that 1A, 3A, 5A. So here our A is -2. I don't see anything for H, so it's 0. I don't see anything for K, so it's 0. So your vertex is 0, 0. It's right there at the middle. And then we have 1A, 3A, 5A. So 1 times A is -2. 3 times A is -6. And 5 times A is -10. So from here, I'm going to go over 1, down 2. Over 1, down 6. 6. And then I've run out of room, so I don't have to go any farther. I'm going to just reflect or mirror the other side. Connect that to make my U shape. Okay. We're going to do the same thing with our next one. So 1/4 x squared. Now, this one, you can, it's going to be a little bit harder to do it this way just because you do have a fraction. So on this one, if you have a fraction out front, what I recommend doing is just making a table of values. And you want your, when you square a number, you want it to be divisible by 4. So I'm going to plug in, let's see, I know 2 squared is 4, so I'm going to use 2. And I know if I do 4, it's going to be divisible by 4. And then, oh, and we can always do 0. I'll slide 0 in at the beginning because it'll be 0, 0. All right, so 1/4 times 2 squared is 1/4 times 4 is 1. And then 4, you have 1/4 times 4 squared. So it's 1/4 of 16 is 4. Okay? So we'll go to 0, 0, then 2, 1, so 2, 1, and then 4, 4. All right, we can mirror to the other side. And you'll notice that this time our U is definitely flatter or fatter. Okay, so that's the difference. And we talked about that. If there's a whole number, it's skinnier. If there's a fraction, it's fatter. And I think you have one very similar to this in your Math Excel. So I would probably use the same three numbers, 0, 2, and 4. It'll probably work out for you if there's a 4 on the bottom. If it was 3, I would think multiples of 3 or factors of 3. All right, on our next one, we're going to graph two different ones. So we have y equals x squared. So that's our parent function. We've done it a couple times, so I think we can graph it quickly. 0, 0. We go over 1, up 1, over 1, up 3, and over 1, up 5. Can mirror it to the other side. Okay. So that's y equals x squared. Now I'm going to use the same thing. I'm going to use a green to do this one. Now this one has a -4 on the end. So that means I'm going to move down 4. And I'm not doing anything else. So it's the same shape, just moved down 4. So 1, 2, 3, 4. Over 1, up 1. Over 1, up 3. And over 1, up 5. 5. Okay, and then again, I can just mirror on the other side and make my V shape. Or my U shape. Sorry, I think I keep calling it a V shape, but I really mean U. It's a U, a parabola. Okay, so you're going to have some problems like this where you have to decide how it's moved. So that number on the outside tells you if you're moving up or down. Remember, if it's negative, it's down. Positive is up. And you can have a number inside parentheses with X. And that can tell you if you're moving up, down. It can tell you if you're moving left or right. So outside is up, down. Inside is left or right. Okay. Now, the next one is asking us to graph this quadratic function and then graph the axis of symmetry. So let's look at what we've got here. So A is 3, and then our H is positive 2. So that means that we're moving left 2. All right. So H is 2, K is 0. So our vertex is -2, 0. So -2, 0 is there. And our A is 3. So 1 times A, 3 times A, and 5 times A. So that's 3, 9, and 15. So over 1, up 3. Over 1 and up 9. And off the chart a little bit, but that's all right. We'll get it figured out. And then we can just mirror on the other side. That's close enough. And then the axis of symmetry is just x equals that. So x equals -2. So we get a -2, and we're going to make a dotted line right down the middle. Okay. Next, write a quadratic function to model the graph. So we're going to look at this a couple different ways. So first we need to find the vertex. So our vertex is -5, 1. We're going to use that. We know -5 is H, 1 is K. And let's look and see if we can find our A. We go up 1, over 1, or over 1, up 1, over 1, up 3, over 1, up 5. So that tells me that A is just 1 because it's my 1, 3, 5. All right. And let's see. Let's fill in our function. So f of x equals A, x minus h squared plus k. All right, so we have f of x equals, we know a is 1, and then we have x, the opposite of h, so positive 5 squared, and then we went up 1, so plus 1. So when you're looking at a graph and writing a function, really you just need to find the vertex and then decide what your a is. So see if you're going over 1, up 1, over 1, up 3, over 1, up 5. Okay, if you are, then your a is just 1. If you're going up 1 over 2, or over 1 up 2, over 1 and up 6, over 1 and up 10, then you know your a is 2. Okay. All right, next, write the equation of the parabola in vertex form. Okay, and I'm going to have to pause for just 1 second, guys. I do apologize, but I'll be right back. Okay, sorry about that interruption. Now, we're going to write the equation of the parabola in vertex form. So you'll notice over here on the graph, you're given a parabola, you're given the vertex, and you're given a point. So our vertex is 3, 6. So that tells us h and k. The point is 1, -2. So that tells us x and y. So we're going to use our vertex form. Y equals a times x minus h squared plus k. We're going to fill in what we know and solve for a. So our y is -2. Our a is unknown. We have x minus h squared. So x is 1 minus 3. Let me square that. And then plus 6. So that's -2 equals a. 1 minus 3 is -2. Squared is 4. And then we have plus 6. We can subtract 6 from both sides and get -8 equals a times 4. Divide by 4. And we get -2 equals a. So now we can take our h and our k and our a and plug it back in. So let's see. Y equals -2 times the quantity x minus 3 squared plus 6. And that's your answer. Okay? So you're just taking what you're given. You're given h and k, you're given x and y. Plug it in, solve for a, and then make your final equation. All right, we're going to do the same thing here. Here we don't need a graph. We're just writing the equation. So our vertex gives us h and k. Our point gives us x and y. So we're going to do y equals a times the quantity x minus h squared plus k. Our y is 8. We don't know a. Our x is 3. We're minusing h, which is 4. And then plus 1. 3 minus 4 is -1. -1 squared is just 1. So that's a times 1 plus 1. So we know that's just an a. We subtract 1 on both sides and get 7 equals a. So we can make our vertex form. Y equals our a, parentheses, x minus 4 squared plus 1. Okay. Next, you're going to be asked to complete the table of values and graph the function. So I can't remember on Math Excel if it wants you to, I think it wants you to do the table and then graph it. But if you just had to graph it on your own, like if we were in person or you're on ACT, something like that, you should know your basic parabola. And then if you have plus 4 on the end, you're just moving up 4. So you don't really need all the values, but you do need to know how to plug values in and see what they should be. So we have -2 squared plus 4, and that's 4 plus 4 is 8. -1 squared plus 4 is 5. 0 squared plus 4 is 4. 1 squared plus 4 is 5. And then 2 squared plus 4 is 8. And you'll notice this pattern. That's because it's the same on both sides of the vertex. That's where we get that symmetry, or that axis of symmetry. So we can graph it -2, 8, -1, 5, 0, 4, and then you can just mirror it, or you can graph those other points. Okay? Should be easy peasy. And then our last one, complete the table of values and graph the function. And I think that I just forgot to put the values in here. I think that it gives you those, but let me double check and make sure you don't have to come up with your own. Okay, I was correct. You don't have to come up with your own. It gives you the values. So we have negative, the quantity, -2 squared minus 2. So -2 squared is 4. So that's -4 minus 2 is -6. With negative of -1 squared minus 2. So -1 squared is 1. It's -1 minus 2 is -3. We plug in 0. So that's 0 minus 2 is -2. Then plug in a 1. Oh, minus 2 gives us -2. Or -3. So sorry. -1 minus 3. And we know that it should mirror. So negative of 2 squared minus 2 is -6. All right? So -2, -6, -1, -3, 0, -2, and then you can mirror or plot the other points. And we've got our nice upside down U shape. And if you just looked at the equation, you should be able to see that negative in front means it's going to be turned upside down. That -2 on the end means you're going to be moved down 2. So your vertex is down 2. And so if you were going to look at this and pick out the vertex, your vertex would be 0, -2. If you were to go up here, your vertex would be 0, 4, okay, and so on. So it's always important to know, if you're looking at a quadratic function or equation, you need to be able to pick out the vertex and know where that's going to be. Because if you know where the vertex is and you know A, you can graph any of the parabolas. Okay, so that's all of our examples. That should take you through the problems in Math Excel. If you need help, please let me know. If you need me to explain something differently, please let me know. I would be happy to assist you. But practice these. Again, you can print off those blank copies if you want to. If you want to try it on your own, you're more than welcome to. But have a great rest of the day.